Hi, I'm your code coder. Today I'm going to make you great, help you innovate. We are talking about Swift classes. We're in Xcode, we're in Playgrounds. Let's get going. All right, so I'm going to open my Playground that's on my desktop, and we basically have the next part of classes. So this is classes part 2. There's going to be a part 3 also. It's a big topic, but we will get our heads around this. Okay, so I want to talk about this property self because you might see this pop up in um, classes from time to time. I want to talk a little bit more about it. So let's say I have a class called Rocket Ship. You can see it's a class. It has the reserved word class. All reserved words are in purple, as you can see here in Xcode. Very nice. And the Rocket Ship is capitalized, so that's how we know it's a class. Inside the class, we have some property or instance variables or properties, class properties, and we have one called destination. Now we also create an init. Okay, we talked about initializers in the last video, and initializers are basically a function that constructs. It's it's the rules of the class to how to construct the object. Okay, and these inits can take in a parameter, just like you see here. It takes in a parameter of type string, and its name is destination. So this is where the confusion starts. So I have a class property called destination and a input parameter called destination. So how do I know which one is referring to which? Well, if I could use this property self, and that self will say this is my property destination. This has a lot to do with scope. So when I use a destination inside as a parameter, it's only available to that function. All right. If I declare this parameter or this property variable outside of the function, it has a what we call a global scope. All right. So it's good to have it on the outside, but then you need it on the inside also. And so if you have a parameter coming in called destination, and then you have a class property called destination, the way you differ between the two is just use the word self, which means this is the property of the class. Destination is the parameter coming in. Okay, so I guess basically people might ask, well, why do you use the same variable? You could, what if you just use map? Did that, you wouldn't have to use self. You could just do that. But people like using the same because when they're passing parameters and you start passing around a lot of parameters around, and when you start passing a lot of parameters around, it gets confusing to try to keep track of them. So a lot of programmers like to use the same variables. All right, so we will undo that, and then let's go ahead and instantiate that for you. All right, so we go let my rocket should come up here. Yes, it does. If I go here, it'll ask for, here is your properties, and I'll say we're going to go to the moon. Okay, if I run that, you'll see it's basically going to say I have one rocket ship. Okay, and its destination is moon. Okay, so using this, and remember this destination moon, this is a parameter being sent to this parameter here. Okay, and it's stuffed in this side. Right goes into left. Boom, it's now in the property destination. Okay, so very nice. All right, so that's one topic out of the way. Let's talk about a big topic, okay, called class inheritance. Okay, so these classes are objects, and if you take like the human object, for instance, a human can have inheritance. So we inherit things from our fathers and grandfathers and so on. So objects do the same thing. So I'm going to talk about inheritance by way of farm animals, okay? And so here's a farm animal class. This will be the super class, okay, that everyone inherits from. So if you look at it, it has a property named name, and it's of type, it's a farm animal. it has a property number of legs, 4. And you can see, like, if there's something we could pull out of a farm animal, that's going to be put in the superclass. Okay, so you could pick out that they're all farm animals. They all have 4 legs, maybe chickens. So we pull that out and put it in the superclass, and everyone can inherit from it. We might have some functions in there that's certain that all farm animals do. Farm animals don't talk, but I have a say hello function and then a description. Okay, so say hello just says, hello, I'm a farm animal. The description says, I'm a farm animal and I have 4 legs. Okay, because I'm taking that property here. All right, so the big topic now is subclasses. Okay, so here's a subclass. Let's make the first farm animal, let's call it sheep. All right, so farm animal sheep, in order to inherit from farm animal, I just put this colon and then farm animal. Okay, so now it's inheriting all the properties of farm animal. Okay, so it has all these, comes with it. If I want to override anything, because like I said, some farm animals things say different things, have different names, then I use an override keyword. Okay, so let's first override the init. Okay, so if we override the init, first thing I'm going to do is go ahead and initialize, create this class using the supers init. So I'm going to be constructed as a farm animal first, straight up. Okay, then after that, I'm going to go ahead and change, okay, this is the override part. I'm going to change my property name from farm animal to sheep. Okay, and then if I want to override anything else, again, the keyword override or the reserved word, and I could say hello. And instead of saying hello, I'm a farm animal, I'm going to say ba ba, I'm a sheep. And then when I override my description, instead of saying up here, I'm a farm animal, I have 4 legs, I am going to change it to, I'm going to first go ahead and write the super description. So this will actually run the super's description method. And then I'm going to print an additional statement saying I provide wool to make blankets. So if you follow, it'll say I'm a farm animal, I have 4 legs, and it'll print I provide wool to make blankets. So you see how I could override? You see how maybe I'll definitely have to override the amount of legs when it comes to the chicken, right? So let's instantiate a class here, a sheep class, and see what that looks like. So let's say let a sheep equal sheep should come up here. There it is. And I put the parameters. Okay, and let's just say hello. A sheep dot, and should come up with code completion to say hello. And let's also say a sheep dot description. All right, and I'm going to go ahead and run that. And if I run that, you'll see it says I'm a sheep, I have 4 legs, and I provide wool to make blankets. And you see it overrode the name sheep. Okay, and if you remember, we did that right here, name sheep, where before in this description it says I'm a farm animal because you default to farm animal, but now you're a sheep and you change the name to sheep. So now it says I'm a sheep and I have 4 legs. I provide wool to make blankets. Okay, so that's a inherited class and a super class and a subclass, and that's the beginning, just the beginning of this topic. Okay, so let's talk about some more. Okay, so we have farm animal class, and same thing, we have a sheep class, but I'm going to add another one. I'm going to add a class. Okay, you see it says its name's big, it says oink oink. Okay, the description says I bring home the bacon. Sorry, kind of insensitive there, but I didn't know what to put. Anyway, and then we're going to put a chicken, and so this causes the problem. The chicken does different things than other farm animals. Okay, and has 2 legs, so I'm going to override legs. Okay, still going to inherit the super init, but I'm just going to override the name and now the legs. All right, it says bok bok. And then I have some, in the description, I'm going to add some conditional statements and some other things of what the chicken does. Okay, so I take the super description. Okay, I say print I lay eggs. If number of eggs equals 1, then go ahead and print I have 1 egg for you. And else, if number of eggs are greater than 1, greater than 0, and not 1, print I have, the amount of eggs I have. Okay, I'm going to add 2 additional functions. 1, lay an egg, and 2, give up an egg. Okay, and so 1 just counts the eggs, and then these gets all the eggs, gives them to someone, and then sets the count back to 0. Okay, so let's go ahead and instantiate this now and show you what this looks like. All right, so if I go over here and I go let chicken, let's create 2 chickens. Chicken, all right, and then let's go let chicken 2 equal chicken. Say chicken 1. Code completion sometimes is a little bit behind. Okay, all right, so now let's go ahead and set these chickens to some functions. Okay, so chicken 1, let's lay an egg. Okay, all right, so let's see what that looks like. So if I play that, I have an error. Okay, chicken so where's that space come from? Chicken chicken chicken. Some time, give it time. Okay, so over here you'll have to see name chicken, number of legs 2, and then I have 1 egg. Okay, so let's have chicken 2 lay an egg. Okay, so I'm going to turn that off, and I'm going to go chicken 2 lay an egg. Okay, and then I'm going to have them lay a second one so you can see it's counting up. Okay, so if I play it to here, you're going to see now I have chicken, I have number of legs 2, and I have 2 eggs. It's counting up. Okay, so very nice. All right, but this is not very efficient. Okay, so let's go back to our analogy of an array. And remember I said when you're driving the diamond lane, you need more than just 1 body, you need 2, where you get a ticket. And the best scenario would be have a bus full of humans driving downtown to go to work. But on that bus is not, everyone doesn't have the same job. You might have doctors, lawyers, construction workers, whatnot. All right. But the bus it'd be inefficient if we say, okay, this bus is just for construction workers, or this bus is just for lawyers. Okay. The bus wouldn't be very filled. Okay. And it wouldn't be efficient. So how could we make that bus more, I don't know, how could we make it more inclusive? Well, if we made the bus for humans, then we could take all humans, whether they're a doctor, lawyer, construction worker. Okay, so why don't we do an array of farm animals now? And we're going to have a problem because all the farm animals are different. So what makes them the same? They're all farm animals. So we can make an array of farm animals. The array knows that one data type belongs in an array. They're all farm animals, though they're different because they're all going to be subclassed out. So let's take a look at that. All right, so here it is. I have farm animal, same thing. Let's see here. Okay, so yeah, so I have all the farm animals, and now I'm going to create an array of farm animals. Okay, so I'll say let animals equals an array. So there's the opening bracket, okay, staple bracket, and in there I have a sheep, chicken 1, chicken 2, sheep, chicken, sheep, pig. Okay, so we have all those. They're in an array. There's no errors because they're all farm animals, okay, of different type. All right, so now if I run a simple function like this for animal and animals, okay, so I'm going to do a for loop and go through the array. All right, and I'm going to try to detect to see which one is. Okay, and so I use the keyword is. All right, and this is called typecasting. All right, so now I'm going to go ahead and find out what type each farm animal is. All right, so if animal is sheep, I could print say hello. If animal is chicken, I could have the animal say hello also, and then if the animal is pig, say hello. These will all override the hello, and they'll each say the right thing. So let's go ahead and run that, and you'll see now when I run that, it goes through the loop, through the array, it goes to each farm animal, and each farm animal says what it was set up to do. Okay, the sheep says ba, chicken say bok, sheep says ba, And chicken says bawk. Pig says oink oink. Okay, sounds like a nursery rhyme or something. Okay, so that's the first part of it. So that's typecasting. All right, so let's put this back into the bus analogy with people going downtown to work. All right, so this would be like, okay, we're going to get on the bus, and then all the doctors have to sit here, all the lawyers have to sit here, all the construction workers sit here, and you have the bus all partitioned off, okay? And they're all humans, and they're all partitioned off by their job type, but they still all go to downtown together. But now, what if you stop the bus at a certain stop where all the construction workers are off? And would you have to go around the whole bus to go to the doctors? Are you a construction worker? Go to the lawyers. Are you a construction worker? No. Go to the construction. Are you a construction? Oh yeah. Okay. You guys get off here. It'd be very efficient. It'd be better if we just said something like, if you're a construction worker, please get off at the stop. Okay. So we're gonna downcast the super type into the subtype. Downcasting. Right? And we're going to do it with the farm animal analogy. So 2 analogies this morning. Wow, big. Okay, so let's give that a try. Let me see if there's anything else I wanted to do on this one. I guess I have to go ahead and there's 2 types of downcasting. Okay, one we could use an optional force unwrapping, and one we could do an optional unwrapping. So let's try that. Okay, so let's say if I'm a chicken. Yeah, all right, so right here, let's go and say okay, so here's chicken. So let chicken equal animal as a chicken. Okay. Oh, before I do this, why don't I give you an example? My chicken lays eggs, right? So shouldn't I be able to say in here, it says animal, say hello. Can I also just say animal dot lay an egg? I mean, because, you know, animal says hello, we have that, and the chicken has an egg too. And so it's, oh, what? There's something wrong. It says value type has no member lay egg. So animal does not have lay egg, all right? I'm typecasting, but I'm still an animal, okay? I'm not a chicken, all right? So that gives me an error. Interesting. Okay, so how do I make it a chicken so I could use those functions? And you might do something like this. Let chicken equal animal as chicken. Okay, so now I downcast it into a chicken, so now I could use chickens functions. Now I got, oh, see, lay an egg comes up. I downcasted it as a chicken, and then I could go chicken dot description. Okay, and now if I run it, okay, you're going to see that I'm actually laying eggs. Here it is right here. I'm a chicken. I have 2 legs. I lay eggs. I have 1 chicken for you now. Okay. All right. So that's what the description was. So that's downcasting into a chicken. But again, I like that bus analogy. I'm going through the bus and asking each profession, are you, you know, what profession are you? This might be your stop. That's very inefficient. What if I could just check to see if it's a chicken, if it's chicken lay eggs? All right, so let's do that. Or the analogy might go something like this. Actually, let's do something like this. Let's go ahead and lock this off, and let's rewrite it. Let's rewrite the whole thing. All right, so I'm going to do something like this. Okay, so let's go. I'm going to set a variable to hold on to how many eggs that I gather. Okay, I'm going to start at 0 just in case I've already had some eggs. I want to make sure that's at 0. And then let's go for animal in animals. Let's go ahead and put in if let chicken equal animal as a chicken. Okay, so you see the difference here? I'm now saying if you're a construction worker, here's your stop. I'm not sure it's gonna. That's why I have to put the question mark, the optional, because it might come up sheep, and this doesn't pertain to me. So if let chicken animal as chicken, okay, go ahead and I think it's getting errors here because I'm not using chicken yet. All right, and so I'm going to say chicken dot lay an egg. Oops, there's still a problem here with this. If let chicken, let's see, if let chicken animal as chicken, I got to open it because it's in the if statement. Okay, and then I go chicken lay. Here we go. Tab in chicken. Right, so now code completion is saying, yeah, you can lay an egg because you're a chicken. All right, so if I'm a chicken, lay an egg, and then I'm going to print something if I do that. Okay, print. And let's go ahead and say I'm going to pick up all the eggs. Right, period. Right, it looks good. Right, so all right, so if it's its farm, pick eggs. Okay, again, back to bus. If you're a construction worker, here's your exit. Okay, that's the difference between using this one and going to this one and going that. Okay, different optional. All right, so let's see if this is okay. I pick up eggs. Then let's gather them. All right, gathered. Oh, there it is. Gathered eggs. Let's add them up. When I pick up, let's add them up. Chicken equals chicken dot. Let's give up eggs. All right. So I go by the chickens, pick up the eggs. This is efficient because now I don't have to go to the sheep, the pigs, and say, hey, do you have eggs? Do you have? I know they don't have eggs. So I'm going to go buy the chicken, pick up the eggs, say, give me the eggs, reset it to 0, and then it should work just fine. Okay. And then one more thing I'll put here. Let's see here. I feel like I'm missing early for some reason. That closes that. This closes that. And then I'm going to print one more statement. And I'm going to say gathered. This is how many eggs. Gathered. Okay. When I gathered eggs. I think it doesn't like gathered. What do I want? Gather eggs, not gather. Okay. Eggs. Does that look good? Yes, it turns green. Of completion. Good. All right, and then we run it, and then there it is. So I pick up 2 eggs, I pick up 3 eggs, pick up 1 egg, and I gathered 6 eggs today. Why does it do that? Because if you go to our, it's going through sheep, and it picks up from chicken 1, chicken 2, not from sheep, chicken, sheep, so it picks up 3 times. And so chicken 1 had 2 eggs, chicken 3 had another one. Okay, remember these? Okay, and so then picking up 1 egg, and then it adds them all up and says I picked up 6 eggs. All right, so that's a way to loop through using downcasting to make sure my animal is a chicken, to check to see if my animal is a chicken, using an optional call. The word as. Okay, you might look to see that I use as on this one. Okay, the word as a chicken. Okay, just to check for what every animal type is, and then I use the word as with a question mark to see if, or just if you could let it be a chicken. If you let it be a chicken, that's what I have. Okay, pretty good, pretty big topic today. We have one more topic to do on classes. I hope to make you great, help you innovate. Subscribe. See you next time.